Hello everyone, and welcome to video 2 of our SQL tutorial. In this video, I'm going to run through a lot of techniques that we can use to query data. So we're going to be talking about getting and transforming and combining data in different ways. So I'll be showing you a lot of different things that you can do with the SQL select statement. And we're going to run from the very basic, just selecting data from tables. And then by the end, we'll be talking about subqueries with some of the different functions that we can use to change how data is presented whenever it's returned from a select query. First, I wanted to mention Reddit has pretty great resources or communities that are around different kinds of technologies or programming languages. The SQL subreddit is fairly active, but I wanted to mention it because just yesterday there was a post where someone was asking about SQL crash courses. And they mentioned some of the resources that I shared with you after the very first class we had. W3 Schools, for example, is kind of the most standard reference to go learn about SQL or to look things up if you need to check syntax or something like that. So anyway, if you are interested in diving deeper, you might look for that thread about the SQL crash course and see what other people suggested. Generally, you can learn a lot of kind of key SQL skills in a couple hours of work. So hopefully this video series kind of accomplishes that, but if you need something supplemental, I would encourage you to go check that out. All right, so we're going to be talking about select statements this entire video. So this is getting data from an existing database. Select statements are also useful because if we wanted to store the results of a query or some kind of transformation that we do, if you remember in the first video, the very last thing we ended with was we were inserting data into a table using a select statement. So you can combine these things to retrieve and transform data using select, and then you can store it into a table or a view, which I think is where we're going to end this video. So let's go ahead and jump right in. I don't think I need these notes, but they are here. They are in our course notebook in collection. So it's video 2, RDBMS tutorial. So we're going to run through this code, and I'm going to explain kind of what it's doing and some tips for when you are creating these statements to get data. So the first thing I wanted to mention that I have not mentioned before is whenever you are running a query, which would be select some columns from some table, you can use a wildcard, which is this little star here. So if you select star, we're going to use this AdventureWorks customer table, which is in our AdventureWorks database. And again, this is a database provided by Microsoft for a fictitious bicycle company. But if we do just select star from AdventureWorks customer, it's going to give us everything in that table. Sometimes, if you're working with very large tables, you need to be very careful about running select star. So if you recall, I have an anecdote about an analyst who was hired who ran a query just like this, select star, from some table that had billions of rows, and that overloaded the server because there was so much data and it crashed it. So you do need to be careful when you're working with large data sets that if you are hired as an analyst somewhere and you do select star from a really large table, you could cause a lot of problems. So the way to look at data when you're just exploring is generally to do select top 1000 from there. And I think my syntax is right, hopefully. And then that's just going to give us 1,000 rows, which you can see down here in the bottom right. Okay, so this is the safe way to explore data. If you don't want to explicitly name all of the columns in a table, this star is very useful. So here we're getting all of the columns, but only the top 1,000 rows from the customer table. Again, AdventureWorks is a transactional database, so I'm going to be running most of these queries in here. You can kind of see that this database is designed not with human querying in mind. So it is more normalized than, for example, our AdventureWorks data warehouse, which means to get the information we want, we're going to have to combine multiple tables and kind of crawl through them. So the data warehouse is what solves this problem, to where we can just join two tables to get the information we want. Okay, so that is the wildcard, which is just the star. It means all columns. So select all columns from AdventureWorks customer. Another thing you can do with a select statement is you can aggregate data. So here we're going to count the number of customer IDs per territory. We do this by using some sort of aggregation function. So there's count here. There's also sum or average, min, max, kind of what you would expect. So when you have an aggregation function, you need to also have if you don't just want to count all customer IDs in the table, if you want to count them per some other variable, like here, territory ID, then you need to mention everything that you're not aggregating in the group by clause. So when we run this, we're going to get the count of customer IDs, and we're going to call that new column customer count, and then we're going to group it by territory ID. And there we go. So we have every territory ID and the number of customers in each one. So the same format works with any kind of aggregation function. So anything that's not in an aggregation function that you are selecting needs to be in the group by statement. Okay, then there are also several ways that we can filter data. So here we're going to, in this first part, we're selecting everything from sales customer, but perhaps we just want to get a data set that is for a particular territory ID, or we want to narrow this down in some way. Maybe there's only some data in this table that we're interested in looking at. So we can, of course, do a select from the table where the territory ID is 1. So that's just going to limit it to every row that has this criteria that we're mentioning in the where statement. There's also logic that we can add. We could also say, or territory ID equals 2. So there are these logical operators. You can do and. There is also or. So or means that if either of these criteria are met, it's going to return rows that meet that criteria. So now we have territory ID 1 and 2. We can also do and, which would mean that both of the criteria have to be met. So we could also do territory ID is 1 and modified date is equal to this value here. So now both of those must be true in order for a row to be returned. Okay, so this is also an acceptable way to look at data. If you are working with billions of rows, for example, if the server needs to return all several billion rows, then that could potentially overload the memory of the server. So it's a good idea to narrow down the data set to just be what you're interested in looking at, if at all possible. So using where is one acceptable way to do that. Also, within a where clause, you can specify multiple conditions. So here, we're selecting everything from customer where the territory ID is in this list. So this is another kind of logical operation you can do. You can create a list of something. So here we have a list of numbers, could also be a list of strings. And if the territory ID in the customer table is in this list, then it's going to return that data. So we have 1, 3, and 5. Here you can see that any territory ID with 1, 3, or 5 is returned in these results. So here's a list that I explicitly typed out. But another thing that you can do is you can generate a list with a select statement. So here I'm using select everything from customer where territory ID is in, and then I'm generating a list with a whole new query. So you can have subqueries that return data that's then used for the main query here. So if I just run this query that's in the in statement, then we can see what it returns. So it should be a list. All right, so here's a list of 2 territory IDs that's being returned by this subquery. Notice here that I'm introducing a whole new comparison where name is like north. So name is a column that's in sales territory, and the like statement is a string operator. So like allows you to compare 2 strings. So the name column in territory ID is a string. So let's just go look at it real quick. So we're looking at sales.sales territory. All right, and here is name. You can see that it's an invarchar 50. But let's look at this table real quick. So what am I doing? All right, so for this query, I am interested in anything that is north. So I want to return territory IDs 1 and 2, but I don't want to hard code that territory ID 1 and territory ID 2 are the ones I want, because perhaps we get like a north central territory. I don't know. This is maybe not realistic, but I want to show you this string operator, because what it's doing is it's looking for name where name starts with the word north, and then it can be followed by any other characters. So that's what you can do with like. So it's comparing the name string to this string right here. So it's in single quotes, which means that it's a string, and then it starts with north, and then it has this percent sign. When you're using like to compare strings, the percent sign is a wildcard, which means that if the string starts with these letters north and then is followed by any other characters, then this is going to evaluate to true. So if the name is like north followed by any other characters, then this is going to be true. And you can see this because we know that territories 1 and 2 are northeast and northwest, and so those are meeting our conditions. Okay, so this select statement, it returns these 2 territory IDs, which we are going to put in this in condition right here. So where the territory ID is in the list of territory IDs where their name is like North, then it's going to return that. And so we want to return all columns where their territory ID has a name like North. And then we'll get all the columns, or all the rows with territory ID 1 or 2. Okay, so we can use in to create a list of valid values that we want to filter on. We can also use like to define some string conditions. So you can use the wildcard here in creative ways. So we could also add wildcard here. So if it just has the string orth embedded somewhere within the name column, then that would return the same results. We could even do RTH or just anything that has an R, right? So this is a very useful operator to look at string data. There are some other things that you can do with strings to transform the data. For example, we could there are ways that you can clean string data. So let's just look at name. Name. And let's do just the left four characters of the name. You can see here in the left function, it wants you to give it, I think, a column and then the number of characters that you want to return. So if we do this, we're going to take the left 4 characters from name in the sales territory table where the name is like North. And we'll just run that. There you go. So we're manipulating the string. It says no column name, so we could probably call this as, we'll call it trimming, because you could call this a left trim, that we are kind of removing some characters. And then we could also do right, just to get the right 4 characters. There you go. And for the purposes of, to relate this back to data warehousing, we talked about whenever there is a natural key within a table that might have some embedded meaning. So perhaps, you know, there could be an ID that has some information embedded in it. So let's just say that for some reason we made a bad decision at our bike company, and we decided that the customer ID naming scheme is going to be it's going to be 7 digits, and then the last 2 digits, how about 7 digits followed by a dash, and then the last 2 digits are going to identify the sales territory that that customer is in. Okay? Bad idea, but maybe somebody just made this decision in the past for convenience sake. Maybe there was not a field for sales territory, and we wanted to capture this information. Okay, so in this case, it would be useful to do to create a new column that would take the right 2 characters of customer ID and create a new field called sales territory, and create another column that has the left 7 characters of customer ID and create a field that is called like new customer ID or something like that. So in a natural key with embedded information, whenever we're moving it to a warehouse to present to end users, we want to split those things out and retain the original value. So using the right or left statements to get the characters we're interested in would be one way to do that. There's also trim, which I think removes spaces, something like that. So characters and expression. So anyway, there are several different string functions that you can use to kind of manipulate that data. This might not work, but we'll move on if it doesn't. Oh yeah, look. So it removed these spaces. So that's what trim does. There's also, to normalize data, there's a lower function. Guess what that does? Turns everything lowercase. All right, so those are some ways we can manipulate data. I went on a little bit of a rabbit trail with like being a string function. Wanted to show you some other ways that you can manipulate strings. So now let's talk about combining data. So let's start with the AdventureWorks customer table. So I'm looking at this and I'm seeing a lot of different IDs that are not terribly helpful to me. So for example, territory ID, if I'm looking at a report and it has territory ID on it and it's just numbers, I don't know what these numbers mean. So the average business user is probably not going to refer to John Jones is the general manager for Territory 4, right? They're going to use the English word for what that territory is. So in order to get that data in this data set, we are going to need to add information from the sales territory table. You can see the sales territory table has territory ID here, which is the primary key. And then it has details about the territory. So if we want these territory details in this data set, if we want to see which customers are customers in the Northwest territory, then we're going to need to add that table. I want to retain all information that's in the customer table, but I just want to add sales territory information to this data set that I'm already looking at. The way I do that is with a left join. Left join means that everything in the first table that I mention, customer, is going to stay, and then everything from sales territory is going to be added where this condition is met, where the customer table territory ID is equivalent to the sales territory table territory ID. It's going to tack that data right here on the end of this data set. Okay, so left join retains everything in the first table, and then it just adds things in the second table where the condition is met. So I know I want to keep all my customer information, but I just want to add the territory details. So that's what this query is doing. And I'm doing select star, so it's going to give me all the columns from sales territory. And you can see that it is added here on the end. Since we're taking everything from sales territory, now we have 2 territory IDs. You can see that they are equivalent, and the details from sales territory are being added here. So now we could take something like this, and we could aggregate it using descriptive, like the descriptions for sales territory ID. So, for example, name should probably have a better name, actually. So here I'm going to call it territory because that seems to be what it's describing. Group looks a lot to me like I called it country, even though Pacific's not a country. but we want to name it something that's more useful. And then I'm counting the number of customers. So here we're going to see the number of customers per territory. So I wanted to see the territory name. I also wanted to see the country name. And then because I'm mentioning both of those things and using an aggregation function, I am having to have a group by name and group. And then I'm ordering this data by the number of customers descending. So you can add order by to any kind of query at the very end, and it tells it how to organize that information. Okay, so here we can see that the Southwest North America territory has the most customers, followed by Australia, then the Northwest, and the Northeast has the fewest. So we're combining a join with an aggregation, and then we're ordering it. You could add some condition here too. For example, maybe we just want new customers. So you could add a condition in a few different ways. In an aggregation function, it has a unique way to filter data, which is using having. It operates the same way as where, but it's used in aggregations. So we're going to do this condition right here. Having modified date of that. We'll see if that works. Ambiguous column name. So I'm talking about the modified date in the customer table. So we'll specify that. You can see it threw that error. So I guess because, yeah, there's a modified date in both of the tables. So if I'm going to filter it, it's going to, the server wants to know which column I'm talking about. So I'll specify that. Oh, I see. So it's invalid because it is not contained in an aggregate function or the group by clause. So this is how it goes a lot. Sometimes you use trial and error to figure out exactly how the database system is interpreting whatever query you're running. So here's what I'm going to do. I'm going to do having that, and it said it's not an aggregate function or in the group by clause, so we're just going to add it. Group by name, group, and modified date. Oops. And actually, I think that in a group by statement, you can group by things, by data that you don't necessarily want to return. So here I'm grouping by cust modified date so that I can have this condition. There we go. So I don't know if, I think everything in the table actually has this value, but that's one way that you can filter for more information using an aggregate. Okay, so you can see how we're kind of putting these pieces together. So we have the basic select statement, we have a join, and whenever you join these tables together, it's kind of creating a new frame of data that is the combination of these two tables. And then we're selecting stuff from this new pool of data that we're creating by using this join. So the tables join together. We have a lot of different columns that we could use in the select statement. So I guess what the server is actually doing is it's going to join these tables together. It's going to filter the data, and that's kind of the frame that we have, the frame of data that we have to select from. And then we're selecting specific columns or results from the frame of data that's being created by combining these tables on this condition having this attribute. Okay, so these things can be combined into pretty complex and long queries, for example, that join dozens of tables together or have long lists of conditions that we're interested in, or perhaps some more complex logic for kind of formatting and shaping the data. Okay, so that was using a left join, which is retaining all information in the first table. Okay, and then we're filtering it with these conditions with having. So left join is not really limiting data in the first table that's mentioned anyway, but inner join is. So here, if you remember in the customer table, there is a person ID. It is null for most of these values. Null means that there's just no data missing. But you can see that in some cases there is a person ID. So what we want to do is we want to combine the information from customer and the person table, but we only want the results where there is a person ID in the customer table and there is a corresponding ID in the person table. Okay? Here, the naming convention is messed up because the person ID is a foreign key that is in the customer table. Where's our customer table? Yeah, it's a foreign key in the customer table, but through trial and error, I figured out that it corresponds to the business entity ID in the person table. Super annoying because it's not completely intuitive, right? We would expect this to be person ID. Anyway, I'm not sure this is even an oversight by Microsoft in this database because this is how things are a lot. Data's not perfect. It's made by humans that are flawed and make decisions that sometimes don't make sense. Maybe one person made the customer table, another person made the person table. Maybe this was an arbitrary decision. Maybe it was intentional. I don't know, but these annoying things are things that you run across all the time when you're working with real data. So I kind of appreciate that it's like this. So we're doing an inner join, which means only give me the results where this condition is true between these two tables. So inner join means that it's only going to give me where these things have something in common. Where they have these IDs in common, it's only going to give me those results. That means that where person ID is null, I'm not going to get any results because there's no corresponding value in the person table. Okay, so it only gives you, an inner join only gives you the commonality between the two tables. So now I've effectively filtered my customer table to only include things that exist in the person table. And then it's going to combine all the data from both of those tables where that condition is true. So you can see that there is a person ID now. We don't have any null person IDs. And it has the corresponding business entity ID from the person table, along with all this information from the person table. So we get people's names, email, promotion. Not sure what that means. We also have an interesting data type. So this is an XML data type. So it has like a lot of information that's embedded in this. Clearly, it's not for human consumption, but you can see that there's some interesting information that's embedded in this XML schema. So this might be used to present information like on a POS system, point of sale system, or something like that. but you can see it has different attributes that are embedded in this XML file type, which is useful for data interchange between systems. But it's, yeah, kind of weird. This is not something we would have in a data warehouse. So, for example, we might be interested in parsing out like this person's telephone number into its own field. They also have special instructions in here. Anyway, so there's interesting data in here that is not in a format that we would want. So if we were actually like building an ETL process to move this to some sort of reporting database, then we would want to transform this XML somehow. There's probably a function to like read XML data and look for specific fields. Anyway, so with the inner join, we have effectively filtered data in the customer table to only include person IDs that are in the person table. So not unlike our subquery using the in statement. So in SQL, there are multiple ways to do different things, but if you're somewhat familiar with some of the techniques, then you can generally figure out how to do what you need to do. So now let's talk about transforming data. So the first, I guess I found in the person table, I was looking for things that we could transform based on some condition, and I noticed there's not like a gender field. So I'm looking at title, and perhaps we want to infer people's gender based on their title. I don't really know if that's a good idea, but maybe we're doing an analysis and we decide that this might provide some interesting information. Maybe we want to look at sales per gender, but we don't capture someone's gender in our database at all. However, we can infer it. So maybe there is a business rule we have that if somebody's title is senior or Mr., then we can assume that their gender is male, and then if their title is Mrs. Senorita, or Senorita, I guess, Miss or Miss without a dot, then their gender is female. Okay, so this is probably a decision that, if we were going to distribute this widely to the business, we would need to make sure that's legit. Like, are we consistently capturing title? Is title just something that's made up by a person that's entering data? Or is it is an employee doing this data entry? If so, it might be unreliable. We might not want to assume someone's gender. But if it is information being entered by the customer themselves and they say, I am, Mr. Luke Reese, then it's probably okay to say that my gender is male. There are different kind of business rules that can be embedded in the logic in these queries, especially if we're creating like a ETL process or a report that's going to be distributed to many people. We want to make sure that the logic we're using is solid. All right, so we are transforming data. We are going to derive someone's gender from their title. And we're doing that with a case statement. So we have this logic that is transforming the title, or it's generating a new column called gender from someone's title. All right, here's what a case statement is. You start with case, you end with end, and then inside you have different conditions. So I said case when title is in this list of titles, then this is the value that's going to be stored here, M. When the title is in a list of these other values, then the value is going to be F. We could have way more conditions, and then if you want an exception condition where none of these cases are met, you say else, and then you could provide some other value. I said null but you could say like not available or other, right? So you can transform data however you want based on multiple different conditions, and this is all going to be stored in a single field. So you can see it starts with case, ends with end, and then I want to name the field, so I said as gender. All right, and I'm just going to run this so you can see it before I embedded several examples in this particular query. All right, where my gender at? Here we go. So here's our gender. Yeah, I did another transformation. I used replace to replace the period in someone's title with blank. So I am removing the periods in the title field because it annoys me that Miss has a dot sometimes and no dot other times. So I am cleaning that data, right, by removing that little period because, you know, if we were specifying specific conditions and there are these little tiny data entry issues like this, then it can make our query invalid. So perhaps I said when title in Mrs., Senora, or Miss, and then I didn't say, it would be very easy for me to leave off this Miss that does not have a period, and then I'm not accurately transforming my data, right? So anyway, replace can be useful to remove or replace certain characters within strings. Okay, and I created a new field, also called title, when I did that replace. So you can see here it doesn't have any periods. And if we go back and look at the original title field, these have periods. But perhaps it might be a good idea to get rid of the periods in the title before we create our list like this. So we could potentially simplify the list that we have. So I could just have one condition for Miss, right? So if we want to do that, if we want to replace this before we are specifying our conditions, then we need to do it somewhere down here. So whenever you run a select statement, after you say from, this is like the pool of data that you are, the pool of data from which you are selecting specific columns or doing specific transformations, right? So in this pool of data, this is what title looks like. It has senior with a dot, Mr. with a dot, Miss with a dot, and Miss without a dot. So this is our pool of data for this particular query. So that's why we have to specify all of these conditions with a dot. And so whenever we run this query, it generates this pool of data, and then it's selecting certain things from it. So this replace function is being done at the same time this case function is being done. So if we want to replace the values in these strings first, then we need to do it somewhere down here, because up here it's done at the same time. And so we cannot use this new title field. We cannot use this in this case statement up here because it's not generated before we are selecting stuff from this pool of data. All right, so we need to replace this information and then use that pool of data that has the transformed column. We need to use that in a different select statement. Okay, so I'm going to create a subquery that is doing the same thing, but notice in this case statement, I am not including the strings with a period because I'm going to replace them before I run this case statement with this logic. Okay, so how do I get a pool of data where I can use this simplified case statement? So you can see that I'm selecting some data from customer, and then I'm inner joining on a subquery. So this is going to generate a table or some data set that I'm going to join to the customer table. It's selecting everything, and it looks like it's creating a new column called new title. That is the result of replacing the period and title with blank. And then we can run this to see what it looks like. All right, so it's everything from person. And then we have this new column called new title, where anyone with a title, that should have replaced the period with nothing. So yeah, here's the first two people with titles. You can see new title is doing that transformation. And it's including, since I did select star, all the other information in the person table. Okay, so this data set that you see at the bottom here is going to be inner joined to the customer data set on person ID equals business entity ID. So we are basically doing the same thing here because we're select starring from the person table. We're getting all that information, but we're also creating a new title field where we're replacing period with blank. Okay, so we're joining this data set from the subquery on the customer table, and now we can use the new case statement where we're working with the cleaned data to generate the gender field. All right, and then we get our results. So we have new title and gender. Looks how we expect it. So you can hopefully see how you can embed a series of complex logic using subqueries to inner join or left join information. So we can start to combine, transform our data to get a single data set that looks how we want it to. And, you know, in reality, there's probably a lot of these columns we don't care about. I did select star because as I was generating these, I was feeling a little lazy. But if we were to actually productionize this and create, like maybe we're going to use SSIS to run this particular SQL statement to generate a data set that maybe we then use to combine with another data set. Anyway, if we were going to automate this process, we would want to optimize it. We want to make sure that we're only selecting the columns that we need that we will ultimately be using. Because every time you run this statement, you know, the more data that it's moving, the more bandwidth it's taking up. So if we were going to productionize this and like automate this statement, we would want to make sure that it's lean. Right now, it's returning a lot of things we probably don't care about, like row GUID. We probably won't use that for anything. So we would want to make sure that we're selecting specifically the columns we want. And, you know, we do that by, instead of using star, well, it would look something like this, right? Where we explicitly name the columns we want. You know, perhaps we don't care about these, and there. So that's a leaner query that only includes the columns we're concerned with. All right, so this is pretty advanced stuff, right? So we have a join that includes a subquery. I've introduced several different functions. So hopefully you get kind of an idea for the flavor of what kinds of things you can do in SQL. There are other kinds of things that you can include. Like what else did I forget? Like whenever you have a where statement, we're working with like date time field. So there are different kinds of date time functions. Like I think there's a date diff, which could take like a single date and then find the difference from today. Might look something like that. I'm sure this syntax isn't right, but I won't go over that now. If you need to use something like that, then I would encourage you to look at W3 or perhaps SQL or the Microsoft SQL documentation. You can also, if you're working with numerical data, like here we're looking at name, like north, but we could also do like, let's pretend territory ID is an integer that is meaningful. We could do less than 5. So you can specify like the common numeric operators, the equal 5. You can also have an exclamation point, which means not equal to 5. You can also say not equal by doing like this. So different kinds of logical operators you can use here. I think those are fairly intuitive, but especially if you've done any kind of programming before, but like is a string operator, which is maybe not as intuitive. All right, so those are some of the other things that, like logical operators, you can use in a where statement. And then I kind of wanted to show you why a dimensional model might make things a little easier. Okay, so let's just talk about the example that we used earlier, where we were looking at the count of customers per sales territory. So let's look at the data warehouse and see if we can do something like that that's a little easier. Okay, so we're probably going to start with some fact table. So let's look at what's available to us. There may not actually be a fact table for number of customers, but let's see what's available to us. All right, and keep in mind that this data warehouse for AdventureWorks, this would be like a data warehousing team already created this for us. Or perhaps they created it for data warehousing team use, but then they would use this collection of fact and dimension tables to generate data marts, or perhaps just flat files like a CSV file for analysts. So if there's a specific question, or if there is like a specific case, like perhaps marketing has some standard metrics that they want to look at, then we would be able to fairly easily, at least much more easily than using the transactional database, create a data mart, which is like a view of data that they can use for reporting. All right, so we have our customer table in AdventureWorks Data Warehouse. So let's just look at it. Like what is available to us? Great. So it looks like they have broken out a lot of information and put it in one place that is about all of our customers. Cool. So we have their address, their French, Spanish, and English occupations. That's interesting. And education. And we have a customer key, which looks like it will identify a unique customer. Cool. And what else do we have here? So we have different fact tables like internet sales. Looks like it has order quantity. Different kinds of dates. Well, let's just look at how about the quantity of internet sales per English occupation. How's that? So how do we do this? Well, let's take everything from internet sales. Actually, we want a sum of the order quantity. Oops. Sum order quantity as total sales. And we want to organize that by English occupation. This is in the customer table. And internet sales. Okay, so we're going to get order quantity from internet sales fact table. We are going to, let me format this. Also, I haven't mentioned this before, but when we are writing SQL, it is a very good idea to adopt some sort of formatting to make it more readable. So if you see what I've been doing, each time I have a keyword, I tend to make it all caps. I didn't do it here, but here. Each time there's a SQL keyword, I like to make it all caps. And I like to use indentation a lot to make it so that the tables that I'm using and the columns that I'm using are kind of on the same plane. So you can see here, this makes it just a little bit easier to kind of filter out all the keywords. And instead, you can kind of scan and see which columns are involved and which tables are involved, because they're all kind of on the same level, see? All right, so we're building this query. We want the total sales quantity, and we want the English occupation. Hold up, let me establish. So we're going to use fact internet sales, and then we want to join this to the customer table. So we're going to join internet sales. We're going to left join, because I don't want to accidentally lose any data. Left join that table on, we'll alias these just to make it a little easier to specify columns. We'll do it on a.customer key equals b.customer key. Okay. So we have total sales quantity, and we also want like English occupation. The nice thing about specifying tables and like your data frame first, so if you specify your from statement with all of the joins, then it will help you out when you are trying to specify your columns in the select statement up top. Okay, so we have total sales quantity and English occupation from this data set, and then we're going to group by English occupation. I have no idea how many of these there are going to be, but we will order by total sales quantity descending. All right, let's see if that works. The reason I got that error is because the whole demo so far has been querying out of AdventureWorks, not AdventureWorks DW. So that means that I'm connected to the AdventureWorks database. So I'm just going to be more specific and qualify this better with a three-part name to specify the database. Um, yeah, so that should solve that. Try again. Cool. So here's our total sales quantity per English occupation. So you can see there's just a single join with an aggregate function that's involved in this. To answer this specific question, now let's say we wanted to create a data mart, which is like a flat file that has a bunch of data that someone could like dump into Tableau and look at stuff. So here is the same query without any kind of aggregate function. So we're just joining customer and internet sales together. So you can see we have all these different dates. We have a product key. So these are sales information along. We have internet sales along with the customer dimension. So it has all kinds of details about our customer. So you can start to see possibilities here. So you could take any kind of like, I don't know, maybe you want sales by yearly income. So you can see all kinds of analyses we could do, like based off the order quantity and the price, and it's probably like some different kinds of, yeah, promotion key. So let's include some other information. So we have internet sales, customer. Let's add product information. So we are in AdventureWorks DW, dim. There should be some dim product. There we go. So let's just we will also inner join, because if a sale is missing a product, then I don't really care about it. And we better include AdventureWorks DW. That was weird. Inner join that on, let's call this one C, on A. So fact, internet sales, the fact table is going to be our primary like anchoring table since it has foreign keys for all the other things. A dot, what is it, product key equals C dot product key. All right, so this is going to give us a really wide table since we're doing select star. Wide as in it has very many columns. You can see it's taking a while actually. Another thing that you may have to look out for sometimes is if, for example, on this join here, if internet sales, so internet sales, obviously, if they sold to a single customer multiple times, then customer key is going to appear multiple times. So let's say my customer key, I bought things 5 times from the company, so my customer key appears 5 times in internet sales. And then in the customer table, we would assume that there is a single row that has my customer key that describes my demographics. However, if there are two rows in the customer table that meet my customer key, that two rows in the customer table that have my customer key, then whenever I do this join, it's going to duplicate data in the internet sales fact table. And that's because if for a given customer key in the fact table, there are multiple customer keys in the other table, then whenever those are joined, the server doesn't know which one of those I want to keep, so it just does both of them. So it's going to, for each single transaction I have in internet sales, it's going to join both of those rows to that transaction, and it's going to copy that single row. Okay, so that can duplicate data. So you do have to be careful, or you at least should probably verify whenever you're doing these joins that in fact there are distinct customer keys that exist in the DIM customer table. Same thing with the product table, that obviously a single product in the fact table is probably going to be sold multiple times. But if product key 477 exists more than once in the product dimension table, then it will duplicate rows in the results, and that could screw up like your aggregations and your counts. So that's something you need to be careful of on any kind of join. If you're joining on one of them that has duplicate values, then it could unintentionally duplicate your results. And interestingly, this query is taking quite a long time, so I am a little concerned that I might be doing something like that. So I'm going to stop it, actually. Yeah, so it has like 40,000 rows. And actually, I'm a little curious just how many rows are in this fact table. So if you recall from our reading, fact tables tend to have very many rows. So yeah, I may be blowing up the server right now. So just to make sure, let's see how many there are total. No, only 60,000. Well, that's not a lot. So I'll just do top 1,000 just to so we can see these results. All right, so like in the case of this query, whenever I'm selecting all 60,000, it seems to take a while, so I might be interested in limiting this to like having a where clause. Here we go. So let's do the year of the order date is greater than 2011. There we go. All right, so I show you all of this to kind of show you how it's maybe a little more intuitive to work with data that is in a data warehouse, that it uses dimensional modeling. It's a little more intuitive. You start with the fact, and then you can add dimensions as you need them. Whereas if we go back and look at what we were doing, there are some conventions that aren't completely intuitive. So we added like we had a customer sales table and a person table. And then there was a lot of different kinds of jumps that we had to make in order to get the details and things like that. Whereas in the data warehouse, everything is kind of flattened just to make it quite a bit easier to get the information that you need. All right, so now we have all this information, like an overwhelming amount of information, but hey, perhaps let's just assume that like the marketing department is interested in using this. So this is where we're going to end with this video. What if we want to store this query? So this query, let's assume that this returns some useful results that someone is interested in using regularly, in creating a report, or maybe they need to manually look up some information. So we want to create a data mart so that people have access to this. And let's just assume that our data mart, where our whole organization is starting to look at information, is going to be in DWFA 18. So what we're going to do is we want to store this information, but you know, all of this data is already stored in the data warehouse, and so we don't necessarily want to duplicate the storage of the data, but we do want to preserve this query so that people can access it. So how can we do this? So you can create like a virtual table, which is called a view. And it's really easy to create a view. We will call this, and let's see, what do we have? We have customer. We'll just call it marketing data mart. I think it might need to be in its own little. Okay, and we're going to attempt to create this data mart, except I want it to be in DWFA 18 in my schema. Here's my schema. Marketing data mart. Okay, we'll see if this works. Interesting. It says create view does not allow specifying the database as a prefix to the object name. Let's try. I'm not sure which one it's talking about, but this query is already connected to this since I right-clicked and said new query. Okay, so now we have an issue where customer key is specified multiple times, so I cannot do my lazy thing of just using star. So I'm going to pause the video and I'm going to clean this up real quick to show you how to create a view. All right, so I just went through the results of the table and kind of took out what I thought might be interesting for the marketing department to see in their data mart. So for here, I'm going to get rid of create view. But we can see the results here. See, I just specified all of the columns that I thought would be interesting. And I'll go ahead and remove that filter. So let's see how quickly this runs. There we go. So now we just have the good stuff. So we kind of left out all those other columns that we do not care about. So now let's try to dump this into a view. So here's my view, Reese 2760 Marketing Data Mart as, we're going to just paste that query there. Except I don't want the top 1,000, I want everything. So let's see if that works. There we go. So we created a view. Now let's look at it. So it's NDW FA18. So I will just refresh this to make sure. And then it will be in views. Okay, so you can see I created one before, but here's the Marketing Data Mart. So what's happening here? It looks just like a table, right? It has all of these columns, but what it's actually doing is it is not storing data. It's like, I like to think of it as like a virtual table, because every time you read from this view, it is executing that SQL that I used to create the view. See, so whenever you are using this view, it is executing this query. It's going and getting the data from AdventureWorks DW, and then it is presenting it as if it were a table. So this is one way we can store our results. And it's also one technique to make data marts. Once you have a data warehouse, you can kind of create these views of the data that other people can use if they are not comfortable using, like a lot of business users may not be comfortable writing SQL and joining tables together to answer their questions. But the data mart or the data warehouse makes it really easy for us to combine that data in a reusable way, perhaps into views, perhaps into tables, so that the end user can use it for their purposes. And you know, this isn't just for people who are working in data warehousing or ETL. For any kind of reporting function, like when I'm at work, I need to combine a lot of data, and it's rather useful to put it in a form. For example, in AdventureWorks, I like what they did where they separated, like we have customer and product, and then we have internet sales, and we can combine those things as needed into a larger file and then condense the columns that are returned to just the most interesting ones. So this is highly reusable, and it kind of allows you to easily break off your pool of data into little bite-sized chunks or data marts that are for specific functions or specific use cases. So this is a pretty smart way to organize data, kind of in the dimensional model type style, where you have the things that you like to measure that have keys that point to other tables that are the dimensions that are reusable across fact tables. Okay, so that's kind of what our whole book has been about so far. And I hope this was even more helpful to you than the last video. In my opinion, this is kind of the good stuff because we get into actually getting data and transforming it to get it to look like how we want it to. And so these are the SQL skills that are going to serve you well no matter what you end up doing in terms of just getting data and doing analysis. And then hopefully you can add some of the principles of data warehousing to inform how you store that data to make it more reusable, so that when you do things like massive transformations of data, you only need to do it once, and then you can just reuse that logic over and over again. All right. Hope that was helpful to you guys. Hope you're having a good weekend. I will look forward to seeing you all in class on Monday. I would encourage you to pay attention to that view exercise. Creating the view is going to be the next lab that we do. So I will have you combine data from multiple um, tables in AdventureWorks DW to create a flat file and then create a view from it. So I just like to make sure that we're all up to speed on creating joins, at least between tables, and then we'll be creating the view. I should also mention that the best way to learn any of this stuff is to just go play with it in a database. We have our server in the computer lab. Um, you typically will not have such elevated access on a server at any business you work at, so it's a pretty good opportunity to just go play with stuff. Just do not delete anything. That's all I ask. But other than that, you can play around and, for example, in the demo DB, or you can create your own private DB that you mess with. So I'm also going to be adding this view to our trusty OneNote. I'll add it here at the very end so that if you want to reuse some of this syntax, you are welcome to. Okay, that's really it for now. Hope this wasn't horribly long, and I hope it was helpful. See you guys.